Let's talk about linear systems, mixture problems. A mixture problem is a classic variety of linear word problem, linear system word problem. And it involves two equations. One equation involves the number of items. And the second equation involves something about the value of those items, or weight, or some other characteristic of those items. So let's look at a couple of mixture problems. All right, let's take off this idea right here. So two equations. One involves the number of items and one involves the value or the weight of the items. Okay. So here is a classic mixture problem, sometimes also called a coins in my pocket problem. And Mr. Merrill has 3 times as many nickels as he has dimes. The coins have a total value of $1.50. How many of each coin does he have? Well, that's the question that identifies our variables. How many nickels? Let's call n equals the number of nickels. Let's call d being the number of dimes. And we know that he has 3 times as many nickels as dimes. Now be careful here about setting that up. It sounds like 3n is equal to a d, but he has more nickels than he has dimes, so that means that n is equal to 3 times d. He has more nickels. So you take the number of dimes and multiply by 3 to get the nickels. Then it says the coins have a total value of $1.50. Well, in any of these coin problems, you can decide whether you want to work in cents, which involves no decimals, or you can work in dollars, which involves usually 2 decimals. So $1.50 is 150 cents. All right, so we know that the nickels and the dimes in his pocket add up to $1.50. Well, how much is a nickel worth in cents? It's worth 5 cents. So what's a way to say the amount of money he has in nickels? And that would be 5 times the number of nickels. What would be the amount of money, a way to say the amount of money he has in dimes? Well, a dime is worth 10 cents, so 10 times the number of dimes. So my other equation involving the value of the items is 5n plus 10d is equal to 150 cents, not dollars, 150 cents. Well, this is a system of equations. How do you wish to solve it? It looks to me like it's already set up to be solved by substitution. So I can take what n is worth and plug it in for n in the other equation. Then it reads 5 times 3d plus 10d equals 150. That means 15d plus 10d equals 150. So 25d equals 150. And when I divide through by 25, I get d equals 6. What did we say d was? Look over here at our list. D is equal to the number of dimes. Now, our nickels is 3 times the number of dimes, so that must mean n is equal to 18. So he has 6 dimes and 18 nickels. By the way, this problem came off of puzzle page B21, I think. That's a mixture problem involving coins. Here is a mixture problem involving things for sale. And we have a school play at which 340 tickets were sold. And at the till, they counted $810 at the end of the evening. Now they know that some of the tickets were sold for $2. Maybe those are the child's tickets, and some were sold for $3. Maybe those were the adults' tickets. So I'm going to say cheap tickets and expensive tickets. So C is equal to, it says how many tickets of each kind were sold. That's our clue to our variables. C is equal to cheap tickets, the number of cheap tickets, and E is going to be equal to the number of expensive tickets. I should say the number of cheap tickets. Not that $3 is at all expensive to see a school play. This is just a label. Now, what do you know about the number of tickets and 340? Or more specifically, what do you know about the number of cheap tickets, the number of expensive tickets, and 340? This is your items equation, and we know that C plus E had better equal 340. Well, what's a C ticket worth? It's worth $2 each. So the amount of money in my till that is from the $2 tickets would be 2 times C. The amount of money in my till from the $3 tickets would be 3E. And this amount of money and that amount of money needs to add up to 810. This is our values equation. 2C plus 3E equals $810. All right, we have a system. How would you like to solve it? This one will solve pretty easily by multiply and add. I'm going to multiply this first equation through by a -2 so that when I add it to the second equation, the C's will go away. So I'm going to put the result right down here. So -2C minus 2E equals 680, and that will be negative. And I put that together, add. So I have 1E, that's nice, equaling, let's see, 810 take away 700 would be 110 plus 20, so 130. We sold 130 expensive tickets. So how many tickets did we sell cheap? And the answer is, what do you have to add to 130 to make 340? And that would be 210. So cheap tickets equals 210. So we'll write this like this: 130 $3 tickets and 210 $2 tickets. That's your answer. This is a typical problem involving investments. There are two kinds of investments. So the number of items actually has to do with the amount that is invested. And then the value of those items is the rate of return that we're getting for each of those investments. So Dr. D. Jones has a total of $3,000 invested in 2 stocks. Stock A pays dividends at the rate of 6%, and stock B pays at the rate of 8%. If her dividends from the 2 stocks total $220 per year, how much did she invest in each stock? Well, let's call A the amount of invested in stock A, and B is the amount of stock money invested in stock B, and we know that when we add those together, we ought to get $3,000. And now, if stock A pays dividends at the rate of 6%, then the amount she got was 0.06A. That's how much money she got back from that A investment. 6% translates to a decimal, and then we multiply it by her investment to get how much money she made on stock A. Stock B is 8% of B. So this is a value of the items here. And altogether, that money should total $220. Well, what would we like to do here? I think I would like to multiply the second equation through by 100 so that I get rid of all of the decimals. That means it will become 6A plus 8b equals 220 and 2 more zeros. Well, this is now my equation. I'm gonna just do this. Don't look at that one now. Look at the first equation and the third equation. And what can I do to get rid of a variable? Well, this one will work pretty well by substitution. So I'm going to say that equation becomes A equals 3,000 minus B. And I'm going to take what A is worth and plug it in for A right there. So now I have 6 times 3,000 minus B plus 8B equals 22,000. 6 times 3,000 is 18,000 minus 6b plus 8b equals, let's see what happened here. Yeah, 22,000. And I add the b's together, 18,000 plus 2b equals 22,000. So 2b equals 22, take away 18 is 4,000. And so b equals $2,000. So that's the amount he invested in stock B. Now we know he invested $3,000 total. She invested $3,000 total. So that must mean that she's got $1,000 invested in stock A. That's how you set up and work a mixture problem. Look for an equation involving the number of items. Look for an equation involving the values of the items. And then decide how you want to solve it. You can use multiply and add, or you can use substitution.